Welcome, everyone, and thank you so much for joining us today. My name is Susan Welton, Oracle Marketing Manager at Perficient, and I'm excited to be moderating today's webinar on driving digital transformation with machine learning and Oracle Analytics. Before we get started, I want to cover just a few housekeeping items. 2 questions often come up with our online events. Can I get a copy of the slides and a link to the recording after today's presentation? The answer to both questions is yes. We will email you with that information on how to access both the slides and the recording following today's event. Time permitting, we'll have a Q&A session at the end of the event, so please type your questions into the chat box and feel free to do that at any time. Without further delay, I'd like to introduce today's speakers, Shiv Bharti and Mazen Manassa. Shiv is Director of Perficient's Oracle Business Analytics practice. Shiv has successfully led the implementation of more than 75 Oracle BI and custom data warehouse projects and has helped countless clients across industries implement BI solutions to drive value with their technology investments. Mazen is Director in Perficient's Oracle Business Analytics practice. His data warehousing expertise, together with an in-depth knowledge of the OBIE platform, is a result of 11 years of consulting experience. He focuses on assessing the health and scalability of existing client technologies, evaluating roadmaps and scope of new BI solutions, and managing delivery teams. Shiv and Mazen, welcome.
Thank you, Susan. Hi, everyone. Thank you for joining us for this webinar today. So let's take a look at the agenda. I would like to start by giving you a quick overview of Perficient and our business intelligence practice. I'll then talk about the disruptions in the analytics space, the 3 wave of disruptions that we have seen over the past 2 decades, and what we are seeing today, followed by the role that Oracle is playing in the 3rd wave of disruption with machine learning and autonomous data warehouse platforms. I'll then turn it over to Mazen to do a deep dive into how we can perform data discovery, leverage various machine learning capabilities on Oracle Analytics Cloud, along with performing a live demo on a number of business use cases. Finally, we'll open it up for any questions from the audience. So who is Perficient? We are a leading digital transformation consulting firm serving global 2,000 and enterprise customers throughout North America with unparalleled information technology, management consulting, and creative capabilities. Perficient and our digital agency deliver vision, execution, and value with outstanding digital experience, business optimization, and industry solutions. We have a broad network of locations across the U.S. as well as offshore facilities in India and China. Founded in 1997, we are a public company with nearly 3,000 employees. We are an Oracle Platinum Partner and have dedicated pillars for Oracle ERP, Business Intelligence, and Enterprise Performance Management. A little bit about our Oracle BI practice. Our Oracle BI practice has over 15 plus years of experience deploying the Oracle Business Analytics product stack. We are a team of over 200 consultants who have architected, designed, and built complex, scalable data warehouse platforms. To date, we have enabled over 400 plus customers in building leading business intelligence capabilities, from deploying enterprise data warehouse platforms to empowering users with data visualization capabilities. Most recently, we are enabling our customers with their adoption of machine learning and autonomous analytics platforms. So with that, let's jump right into it. I want to start by talking about the disruption that is going on in the analytics and BI market today, which can really be considered as the 3rd wave of disruption. Now, the first wave was 25 to 30 years ago when organizations were building a centralized data warehouse platforms. The capabilities that analytics platforms were expected to provide at that time was the ability to access predefined dashboards and reports by a common semantic layer, ensuring a single source of truth for all the reports and metrics across the enterprise, a data model was designed to fulfill pretty well outlined set of business requirements. Similarly, data consolidation involved, for the most part, pulling data from ERP and CRM platforms, mostly relational table structures. It was very time consuming and involved a lot of manual process even to automate the data consolidation and cleansing process. During this period and the capabilities that were provided, we were always looking back at what had happened with biases around what we should be looking at and how we should analyze our data, since users had to outline exactly what they needed to see before the start of a project. Also, this was very IT-centric and required a long turnaround to fulfill any new insights that the business wanted to get visibility into in order to make a timely decision. This led to a second wave of disruption about a decade ago. The gold rush for various players in the market was to fulfill the void that existed within the business user community, the need to empower the business users, provide more self-service and ad hoc analytics capabilities, empowering users by allowing them to create their own visualizations, mass up data, and create their own reports by connecting to various sources and getting more timely insights, all without the need to learn any kind of coding, essentially helping democratize self-service analytics. There was one challenge, though, that continued to grow, which is the complexity of data structures. The type and speed at which the data complexity continued to grow was exponential. That led to complexity of not being able to truly empower these business users, which brings us to the third wave. Welcome to the modern era of augmented analytics. This is the period we are in now and the next decade. According to Gartner, augmented analytics is the future of data and analytics, an approach that automates insights using machine learning and natural language generation. In this wave, we rely on machines, algorithms to do the job for us, the job of understanding which data sets to connect to and automatically establish the connection, the job of preparing the data for us without any manual intervention, the job of scaling the environment to support the performance needs so it can complete its own tasks. Most importantly, the job of finding the insights at the speed that will have an impact on our business. Now, Oracle is leading the wave of augmented analytics by democratizing machine learning for everyone, not just data scientists or programmers. With powerful machine learning, natural language query, and autonomous data warehouse capabilities, Oracle Analytics Cloud can do the job of finding powerful insights for you and your business. The strengths of Oracle Analytics, according to the Gartner's Magic Quadrant, is natural language, automated insights, cloud presence with optimizing integrations to Oracle ERPs, Oracle Cloud ERPs. Also, product vision around augmented analytics is cited as one of the key strengths. With this platform, you can continue to get a single source of truth for any static dashboards and reports. You can continue to empower your users with performing self-service analytics and data visualization, along with simplifying the process of data consolidation by leveraging the machine learning capabilities to automate data preparation and insights generation. If you take a very simple HR use case of finding insights into employee attrition, with Oracle Analytics Cloud, you can certainly analyze all your workforce profile data, but you can also ask the platform, for example, to explain attrition, where it does the job of automating the process of connecting all your HR data, finding relationships with each other, and discovering powerful insights into employee attributes, behaviors that directly impact attrition. Without you as a business user having to write a single line of code, you could take it even further and use the tool to make predictions based on historical data and all these powerful insights with lightning speed. With so much data today, there are way too many variables and relationships that exist between them, which makes it practically impossible to manually process and get insights. With digital transformations going on, the speed, volume, and variety of data is not getting smaller. It only continues to grow exponentially. The next wave of leading analytics platforms needs to understand these growing data complexities and simplify the process of getting timely insights in the hands of the decision makers. With Oracle Analytics Cloud and its autonomous data warehouse capabilities, you can today, not tomorrow, not in the future, but today, right now, leverage the power of machine learning capabilities of automating data preparation, automating insights generation, using natural language to interact and provide you with the valuable and timely insights. So with that, let me go ahead and transition to Mazen to walk us through the steps, examples, and perform a live demo of a very powerful machine learning capabilities on Oracle Analytics Cloud. Mazen, please take it away.
Thank you, Shiv. So in the rest of the deck here and the demo at the end, what I aim to do is to expand a little bit about what Shiv mentioned in terms of augmented analytics. And what really used to take data scientists to put together is now available for analysts and business analysts to do using Oracle Analytics. So I'm going to walk you through 4 main steps that are the typical steps to go through an exercise like this. First, we want to discover data sources and connect to those data sources. Then we prepare our data, analyze it, and then that's the step where we start thinking about applying machine learning and predictions as a last step. But if we look at the first step here in terms of discovering data sources, Oracle Analytics offers a lot of built-in adapters that makes that function very easy to implement. You can connect to any of the available cloud applications, like, for example, Taleo, Salesforce, or others, or on-premise applications. You can be connecting to your ERP system, for example, and import data from there. Now, once you get the data into OAC or to the Oracle Analytics platform, that can be living in either a relational database or a big data environment if you're dealing with a lot of data. The second step here is to prepare the data before we start analyzing it. So that requires, for example, cleaning the data up, joining different data sets together, or enriching data with other data sources. So there's easy functions within Oracle Analytics to deduplicate data, replace certain values, group certain values together, and apply certain transformations. There are also data flows in Oracle Analytics that will facilitate data preparation. So what we're looking at here, for example, is a workflow that gets data from 2 sources, joins them together, and that's very easy, intuitive to use for an analyst. It doesn't require IT skill set to implement. Now, the workflows that are developed in Oracle Analytics get pushed down to the underlying source system. So if you're using big data with Hadoop and Spark, that's where the execution happens, and that's what's going to allow it to scale to large volumes of data. But that's not a requirement. So if we're starting small with smaller data sets, we don't need to really implement Spark and Hadoop in that case. Now, once we imported data, we prepared it, now it's time to analyze it. And now here's where the powerful features kick in, especially when we start looking at machine learning functions. So it's easy to do drag and drop and create visuals, but that's not it, because we can also implement, as we see here, cluster functions, outlier detections, even forecasting within the visualizations themselves. So we don't have to go somewhere else or use data science skill set to do any of these. They are very easy to implement, as we're going to show you here in the demo in a minute. Now, in addition to those drag and drop machine learning functions, there's an explain feature in Oracle Analytics. That's something I'm going to demo as well, that would allow you to explain one of the several attributes in your data set. And that is going to be giving you really good insights about how that attribute relates to other attributes in your data set. So you're going to be looking at, for example, anomalies in the data or groupings of data that you as a human would not be able to figure out just by looking at the data. But by the machine crunching the numbers, it's going to show you anomalies and correlations that would be hard to find otherwise. So when we get to the fourth step here, which is the prediction, there are several functions that we can leverage. As part of the data flows I mentioned earlier, we can generate forecasts. So we have our historical data coming in, but we can also implement ARIMA or seasonal ARIMA, which are algorithms to forecast based on historical data. And we can store those forecasts in data sets or in a database. Another useful feature is sentiment analysis that we can use. So if you have a lot of comments or textual fields coming into your data, and it's hard to go through all these and read through them, but you want to focus your analysis on the most important parts, you can apply sentiment analysis to either tag these comments as positive, negative, or neutral language. In addition to the built-in functions, there are a lot of custom scripts in Python or R that you can do and develop if you're interested in something more customized. Now, there are also a lot of built-in machine learning models that we can implement. So again, we use data flows to implement these, and these go through the typical machine learning exercise of training the model, and scoring it, and then applying the model against new data sets. So if we look here at this screen, at the bottom of the screen, there's a list of machine learning models that are typical to use. Some of these are numeric predictions. Some of them are classifiers, so it's going to classify data based on predefined values. Some of them are good for binary. That means you have two classes of the data. There's also clustering algorithms and custom algorithms that can be implemented. So we're going to take a look at that, how it works during the demo as well, and create a model throughout. Now, if we look closer at these different machine learning algorithms that are available in Oracle Analytics, some of them are supervised learning type of algorithms. So that means they are, in this case, the first example we're looking at are numeric predictions. So ideally, we use these to predict, based on new data coming in, the forecast. So for example, how many units do we need to stock in our warehouse inventory? Or how much revenue do we anticipate to do over the next year? These are good examples to leverage the numeric prediction models. And there are several scripts that are built in that we can use, like linear regression or random forest. So, and also you can implement custom ones if you want to do something more sophisticated. Another example of supervised learning, as they're called, is the multi-classifier and the binary classifier. So here is basically a model which we can use against predefined classes. So if we have a list of products that our company produces, the classes are basically the list of products. These are known values, but we want to be able to predict what is the next best product to recommend to a customer. Or if you think about cross-selling, what is the likelihood to cross-sell to our other products and services? So this is where we can use multi-classifier type of prediction model. And again, there's multiple scripts we can implement, like CART, Naive Bayes, neural networks, random forest, and SVM. So these are very typical scripts that are common in the industry for those types of machine learning models. If we look at the binary classification type of models, again, these are supervised learning. They're supervised, again, because the outcome is it's kind of known. You know whether something is, for example, in this case, win or loss of a sales opportunity. We know that the values are going to be either win or loss. We just have to train the model to predict for future sales opportunities whether they're going to be a win or a loss. Another example is which customers are more likely to renew our service. Again, it's binary because it's a yes or no question. So that's why we implement binary classification predictions for those cases. Now, in addition to the supervised learning, there's also what we call unsupervised learning, machine learning models. And clustering is a good example of that. So here it's different because we don't know the values that we are predicting. We depend on the model itself to understand the structure of the data without a known classification. So there's a couple of scripts that are built into Oracle Analytics to do that. One of them is hierarchical clustering, and the second one is k-means. And some of the examples to implement that is, for example, which customers cohort are more responsive to specific types of trade promotions. So if you're doing marketing campaigns and you want to segment customers, clustering models are a great example to do that. Or, for example, what type of product packaging is more popular by location, age group, household income, etc. So again, we want to segment customers to see which are more responsive to certain type of product packaging. All right, so this summarizes the different type of models we can think of and implement. Now, what does the typical workflow look like when we want to do machine learning? So traditionally, we look at historical data that we already have, and we break it down into two chunks. So the first bigger chunk is the training data. We use that to train our machine learning model. And typically that's 75%, more or less, of the historical data we have. And then we use the remaining part, which is what we call the validation data set. And that's about 25%, or the remaining part, to score the model and look at whether it's going to be an accurate model to use or do we need to tweak it. So that's what it takes. It takes 3 steps really to do it. The first part is to train the data using the historical data training part. Then we score it using the validation data. And the third part is where we apply the model against new data sets that are coming in. Now with Oracle Analytics, the exercise becomes simpler because we're doing a different approach. We're creating a data flow, and yes, we're feeding it the historical data, but we don't have to worry about segregating data between training data and validation data. The model itself is going to give us the trained machine learning model together with the score. So there's no exercise involved in, okay, what is a record that qualifies as a validation data set versus training data set, because that is a breakdown that requires, very random selection of a validation data set. So Oracle Analytics is going to handle that for us. But if we choose to do that manually, for some reason, we can still do it as well during data flows. We can break up our data, historical data, into training versus validation data sets and do it the traditional way as well. And so once we have a model and a score that we are happy with, then we can use that model against new data sets. And we have a couple of different options of doing that. The first one, as mentioned here, would be to apply it directly in data visualizations. So drag and drop functionality. Second approach, again, is drag and drop, but it requires creating a data flow, storing the data before we can visualize it. So if you're interested in storing the data with the forecast or with the prediction, you would go for option 2, create a data flow, and do that before you start reporting on the predictions. So with that, I get to the demo section of the webinar. So I'm going to switch over to the browser and demo the Oracle Analytics machine learning capabilities. I'm going to start with the first demo here that has to do with the Oracle Data Visualization Advanced Analytics Functions. In this use case, I'm going to be looking at HR data and see how we can trend and forecast voluntary terminations based on HR system data. So I have a canvas here that I've started working on, and if we look at the left side, we've got different data sets. The one I'm going to be using in this demo is the consolidated terminations. And if we start with something simple, I'm going to select the actual termination date and the number of terminations. And I'm going to ask the tool to create a visualization for me with those two fields. So it comes back with a line graph. That's the trend, daily trend of terminations. And I'm going to add the termination action to that. So I just double click on that, and it's going to differentiate voluntary versus involuntary terminations. Now I can apply filters. So say I want to focus my analysis on everything generated after August of last year. You'd see the whole canvas is now reflecting my filter selection. But this is really hard to interpret what's going on with these two trends. So green is voluntary terminations, blue is involuntary. But I'm going to start using some of the advanced functions, like right-clicking on the visual and say Add Trend Line. So now I'm able to see easily that the blue line is trending upwards, so that's involuntary, while the voluntary terminations are slightly decreasing over time. Similarly, I'm going to right-click and generate a forecast. So I'm going to say Add Forecast. And now we notice on the lower left side of the screen, there's more information we can define for our forecast. So the method here would be next, the period is 3, and since I'm using the actual termination date, my period here is based on number of days. So I'm going to say forecast 30 days into the future, and the model it's using is called seasonal arena. So that's a good model to track historical seasonality in the data. For example, if you have special operations going on in winter or during the holiday season in December, there may be special yearly trends. Seasonal ARIMA is great to track those for future forecasts. So in my example, I'm able here to quickly predict the next 30 days how my terminations are trending. You'd see again that the blue line is trending up. That's the involuntary, whereas voluntary terminations are going down. In a similar way, we can apply other type of quick advanced functions such as clustering and outlier detection, and the other ones we used already, trend line and forecast. So with this, I'm going to switch now to show you something else, which is going to generate for us insights into a data set. Again, HR data set I'm going to be dealing with, but it's more about exit surveys this time. So with this data set, I've got responses from employees who have terminated, and these are typically filled out by voluntary terminations. And usually these surveys get to be long. They have a lot of questions, a lot of insights that the company want to gain about what these employees like or dislike about the company. So if you look at the left side, there's a lot of fields that we collect from these surveys, and it's hard to understand the correlation between the different answers. The visuals we're looking at here are the end result of my machine learning exercise, if we may. But I haven't really created these manually. These were automatically generated for me using Oracle Analytics. And that's what I'm going to show you in this demo. So if I go to one of the attributes of the survey, one of the questions was whether you recommend the company to other people or not. So that's question 11. I'm going to right-click and say create or explain recommend to others. So what happens now when I click explain, it's going to crunch through all the values, all the results, and it comes back with this pop-up that shows me different insights into the survey data. The first part is the basic facts. So in this case, it's showing me that out of all the different responses, 69% said yes, they would recommend to others. 24% said no, and then I got 6% of no answer to that question. And if I scroll down, I'm going to start seeing a lot of automatically generated visuals that correlate the recommend to other question to all the other attributes in the survey. For example, years of service. Those who spend more time with the company are more likely to respond yes to that question. Now, if you look on the left side, there's other areas we can dig into. For example, the key drivers that would cause someone to recommend or not to recommend the company to others. There's going to be a lot of attributes and questions in the survey, so it's hard to figure out where to focus our analysis. But this key drivers tab is going to show us what are the elements that are most likely going to impact this question. And then there's these segments that explain the attribute I clicked on. These segments are going to show me the groups of different people in this case who would answer one way or the other. So again, these are leveraging all the machine learning clustering functions, but we're not doing anything. It's just point and click, and it's going to produce all that for us. And then the fourth part is the anomalies. So this is great for identifying exceptions, things that do not follow the common trends in the data. So we'll look at these one by one. But what's cool about this as well is that I can save these visuals for me if I just click them, and then they're going to be saved on my project. I don't have to come back here. So I'm going to go through it quickly and add some of these that I may be interested in just by checking the marks. And if we're looking at the correlation between the recommend to other question and all the other questions, let's say I want to focus on where the answer is no, so I can quickly go through them and look for any areas. For example, this one, dislike benefits, looks like that's going to impact our recommend to other question. And I keep going down. And if I want to focus on those who answered no, I can quickly see here that this category, which has to do with the dislike of the treatment of employees, a high percentage said no to that. So I'm going to include that and look at it later on. So again, a lot of visuals. So I'm just going to select a few of them and then go to the second tab, which is the key drivers. So out of all the different columns in my data set, all the different questions, looks like it found two main attributes that are going to impact the recommendation to others. The first one was a question about whether an employee thinks there are obstacles that hinders their career progress. So obstacle was a key differentiator. And the other one was the sentiment analysis on the comments that the exiting employee would enter. So again, machine learning functions automatically implemented to figure out whether the comments they entered were negative or positive. So in this case, it's showing me all values, but say I want to focus on just those who answered no to that question and see what's going on with those. So it shows me that those who answered two means yes, there are obstacles, are more likely not to recommend to others. If we go to the segment section, that's where we have the results of the clustering functions implemented for us. It's going to show us groups of people who behave in a similar way. So in this case, it's showing me that 95% who recommended to others belong to certain business units, have certain job functions, and so on. And the final one is what's going to show us the anomalies or the exceptions in the data. So again here, I filtered on the responses that are no, and it's showing me that, for example, the first one for HR segment RS, the blue line is the actual value, so there are 19 of those, but the green line is the expected value. So it's way above the expected value. This is a good anomaly or exception to focus our analysis on this HR segment because it's trending above the normal values. So again, that's normal compared to other segments, other countries, and other attributes in the data set. So I'm going to select this one to include in my project. A similar analysis I got here by country. So for Norway, we see again Norway is going way above the expected value. I'm going to highlight that one as well. And let's see what else is there. So there's one by job function. So we'll look at the different job functions, expected answers, and we see engineering is one where people are answering no more than expected. So say I do my selections. Now I'm going to say add selected. So all the visuals I've selected are going to be automatically created for me on a canvas. And I can then update those and change them or present them in presentation format as I see fit. All right, so this concludes the second part of the demo. So we looked at drag and drop functions that we can add to our visuals. We looked at the explain feature, which is going to be automatically generated visuals for us with different clustering and machine learning insights. The third part of the demo is going to be more about training a model from scratch and then applying it against new data. So to do that, I'm going to create what we call a data flow. And when I do that, it's going to ask me what data set I want to use. So here's where I can create a new data set by connecting to the source system, importing data. In my case, I'm going to use the consolidated terminations data set. So again, an HR use case, we're looking at data that has been consolidated from different systems to track employee terminations. And you'll notice on the left side, I have a list of all the columns that are available in my data set. And down below, I have a preview of the data that I am working with. And what's cool about data flows is I can see a preview of the data on each and every step along the way to make sure that my changes are reflected properly. Now, when I click on the plus sign, it's going to give me a list of the different transformations that I can apply. For example, I want to filter my data set. I would click here, select the column I want to filter on. Say I want to filter on the source column. So because this data was loaded from different systems, I want to clean it up, make sure that there's no extra records that do not need to be in there. So I'm going to exclude all the null values. And I can apply a different transformation. The one I want to use next is the select columns. So this is very important when doing machine learning model training because we want to be careful what columns we keep as input to our model. So in this example, what I'm doing is I want to predict the type of termination, if someone's going to be voluntarily terminating or not. Now, when I look at our employee data in our HR system, we don't have termination data, obviously, because these are all current employees. They haven't terminated. So I want to be careful when I train my data on historical data to exclude any columns that have to do with termination, except for one column, which I'm going to mention next. So here's the list of columns in my historical data. I'm going to go through it. For example, years of service would be something I want to exclude because that is after the fact. Actual term date as well. And also want to make sure to exclude columns that do not make sense to include when we train a machine learning model. For example, the person number or ID. These are specific attributes that do not help when we want to predict new values based on new data. But for example, we want to keep for the job title, the HR segment, the work location. These are all factors that may impact or correlate to what the behavior may be. Okay, so the only column I want to keep that may relate to termination is the termination action. So that's what's going to predict whether someone's going to be voluntarily or involuntarily terminating. So I selected the columns I want to exclude. I'm going to say remove selected. And next is when I'm going to apply the model I want to train. So down here is the list of different algorithms available. I'm going to do a binary classifier. And these are the different scripts that are built into Oracle Analytics for binary classifications. So it's binary because I'm doing one of two values, either voluntary or involuntary termination. And in my case, I'm going to use the naive-Bayes classification, but you can choose different types of scripts and score each one of them, see which one would be more effective in the prediction. Now, when I select the binary classifier, it's going to, first of all, ask me what is the target column? What is the value I'm trying to predict? In my case, I'm going to be predicting the termination action. And the positive class in target, it defaults to yes, but in my case, it's different. So if I look at the preview of the data for termination action, you would see that it can be either voluntary or involuntary in the data set. So I'm going to say voluntary is my positive class in target. And there are other attributes in the model itself that we can set, but I want to point your attention to one of them really, which is the train partition percent. So it's 80%, and this is really what it means when I talked about the training data versus the validation data. So I talked about the 75-25% earlier. Here it's defaulting to 80%, but I can change it. That means it's going to be using 80% of the historical data for training the model, scoring it, and then the remaining part would be, the 80% would be for training it, and then the remaining 20% would be for scoring it. So that's all I have to do to select my the model I want to train. I'm going to save it, and the model name, I'm going to give it a name. So it's going to be, for example, predict term action. And when I click Save, it's going to ask me to name the data flow so I can refer to it and change it later on if I need to. And now I can run the data flow. So by hitting Run Data Flow, it's going to be doing two things here. The first part is it's going to be creating a model using 80% of the consolidated termination data set. And then after the model is created, it's going to use the remaining 20% to score the model. And I can then show you next here how I can get to the score, or they call it the quality of the model, to make sure it's accurate enough for my prediction purposes. So the next step I'm going to do here is to show you how to apply the model once it's done using a new data set, which is basically the list of employees in my HR system, which is current data. All right, so it tells me that the data flow has completed. Now I can go to the machine learning section of my platform and look at the data model, the machine learning model. So it's the predict term action created today. created just now, and I'm going to inspect that model, go to the Quality tab, and look at the score of that. So what this tells me is that the model accuracy is really 64%. So again, this scoring is based on the historical data, the 20%, and there's more input insight into it. It shows me the mapping between actual values versus predicted values. And the blue boxes are the correct predictions. The red ones are the incorrect predictions. So basically, if I add up the 490 plus 158, divide by the total occurrences, that would be my 64%, which is the model accuracy. So in addition to this score, we have more information about the model itself. If I click on the summary, for example, you're going to notice in the background there's more attributes about the model that we can look at, or at the statistics part. So if interested, you can dig into the type of model that's generated, the precision, the recall and support, and look at how you can make it better. But for now, I'm going to go create a project using the new model I just created. So here's where I'm going to go through the final part of applying the model to new data. So I'm going to use now a current employee record data set. That would be something that represents the current employees, so no termination data here. And if I want to do something simple to start with, let me select person number, list of person identifiers, and then I want to click on the create scenario and then select the model that I've just created. Now in here you may have different models that you tried, using different algorithms. This is a good way to compare each one of them. In this case, I'm just going to select the one I created. And we would notice that now I have the predicted term action here, folder generated, and I can drag over the termination action prediction column next to the person number. And that's going to start showing you predicted values against the employees. And in addition to the predicted value, it's going to show us the prediction confidence, the factor that is going to identify how accurate that prediction was. So we've got the person number, predicted value, prediction confidence. Now this is very detailed, but it gets more interesting if you do it at a higher level, say at a country level. I'm going to replace person number with country. And I can do visuals as well. So I'm going to select the country and the termination action and create a best visualization. So it's going to come back with an easy way for me to interpret the data. So it comes back with a horizontal bar graph, and we can easily see, for example, in certain areas where there's high numbers or ratios of involuntary termination predictions. For example, this country here, Indonesia, we see a much higher ratio with the involuntary terminations. So we can correct our hiring operations there and take actions accordingly. So with this, I get to the conclusion of the demo part of the webinar. And I'm going to turn it back to Susan for a couple more notes and handle any questions that were entered. So with that, back to you, Susan.
Bye. Thank you, Mazen. As Mazen mentioned, we're going to start the Q&A session of today's event. So you should see that Q&A tab in the lower left-hand corner of your screen. This is where you actually type your question in. So we're going to be taking a look at some of the questions that have come in initially throughout the presentation, but please go ahead and take the time now to type in any questions that you might have that have occurred to you throughout the event. And I do want to let you know that if for some reason we don't get a chance to get to your question, don't worry. We will definitely make sure that someone gets back to you after today's event. So with that, we'll go ahead and get started and see what we have that's come in. Looks like we have a question here, Mazen, from Bob. Bob wants to know, how do you compare multiple prediction models? Wants to know if he can use multiple models at the same time to compare the results.
Yeah, so we can definitely do several models together. So there's a couple of things to think about when we're looking at multiple models. The first is to score these models. So we create a separate data flow like I've done here, one for each model. And we basically have to end up with, if we're doing 3 models, 3 data flows, and then 3 models that we can score separately and compare the score of each. And then the second thing we can do is to, when I create a scenario on the canvas, we create 3 scenarios in this case because we're dealing with 3 models, and we can show them side by side what the prediction or the outcome would be. It could be, for example, a trend graph with 3 different lines, one for each model, so we can compare how they behave against each other. A very typical use case.
Thank you, Mazen. Looks like we have another question here from Anil. Anil wants to know, if we create customer clustering in data visualization, can it be integrated with our CX system?
Sure. So it must be so CX, customer experience systems, or if you have CRM systems where you have a lot of customer information, you use data visualization, do clustering. So how do you integrate the data back? So I talked about a couple ways of doing clustering, the data visualization where you drag and drop, but then if you want to integrate with your system, that's where you want to use the data flow approach, because with data flow you can save the outcome of the prediction. You can save it in a database like a relational table, and then that can be fed back to your CX system so you can see it together with the rest of your customer information. There's also ways where we can embed data visualizations from Oracle Analytics back into your CX system, so you'll see a canvas with visuals right into your CX system, so you don't have to go out and log into a separate platform to see it. So there's different ways of integrating through data flow or through embedded visuals that can be accomplished.
Great. It looks like we have another question here. This one is from Ellen. Ellen would like to know, once an ML model is created, how can it stay up to date with the latest data?
Okay, so the exercise I went through to create a data flow, basically we will have to retrain the model periodically, and that can be done through scheduling the data flow. It's not something that we have to do manually. We can schedule the training data flow to run on a certain schedule. We also have to make sure that the source historical data is not fixed. So sometimes you want to upload data from a spreadsheet, but if you're looking to keep it up to date as the data changes historically, then you may want to connect directly to the source system and dynamically pull the data from there so it's always up to date. And you basically would end up with a machine learning model that's always getting trained and up to date with your latest historical data set.
It looks like we have one last question here from Anil again. What is the best way to do ML on POS data? Is a reporting data model necessary, or can the data be imported through data files?
So POS, probably point of sale systems here. So there's typically databases behind the point of sale systems, and I guess the question is, do you need to build a reporting database or a data warehouse? So typically you would start, if you want to start with data files, like you're saying, that's a good place to start where you do discovery on the data files that you're trying to figure out what type of machine learning models may be helpful. But then if you want to make it more seamless, then yes, you definitely want to build a data model. And here's where something like Autonomous Data Warehouse from Oracle may be very useful together with OAC because these work very well together. We're basically putting POS data, customer information, you may be having product item information, and so yeah, we would build a data model and then have the machine learning happen on top of that data model. So both options would be possible. It just depends on what type of automation and integration is possible with your POS system.
Thank you, Mazen. As we're getting close to the top of the hour before we close today's event, I want to make sure that I share with everyone that we will be exhibiting at Collaborate. If you are attending the show or if you happen to be attending Modern Business Experience as well, Perficient will be exhibiting at both. We actually have 8 speaking sessions at Collaborate. So if you do intend to head to San Antonio in April, please make sure that you stop by, look up our sessions online. We'd love to have you attend one of our events and meet some of our subject matter experts in person. And before we close today's event, I just want to make sure that you are aware that we have an incredible blog that I highly recommend you check out if you hadn't had an opportunity to read any of the blog posts that our various team members from both our ERP, EPM, and BI practice write and share their knowledge. So it's a great resource. We refer to it often in even our webinars like we do today. There's just great content that's shared throughout those blog posts, so please check it out. And with that, I really want to thank our presenters today, Shiv and Mazen. Thank you so much for your time. Thank you for providing us that really in-depth demo of the product. And as a reminder to any of you on the call today that are interested in reviewing that demo again or in taking a look at the slides associated with the presentation, we will be sharing that information via an email. You should get that in about 24 hours after today's event. So please look for that email and by all means share with your friends. So with that, we want to thank you for joining our event today, and we hope to see you online in